Okay, the first thing we're going to do for today's lesson is we're going to make this foldable. So I need you to take your sheet of paper that looks like this and cut all of the dotted lines. Okay, so go ahead and cut out all of the dotted lines. Pause the video until you have done that. Okay, hopefully you have cut out all of the dotted lines for this foldable. The next thing that we're going to do for this foldable is you want all of the lines facing you, put the glue on the back, and you're going to take this and fold it down and take this and fold it down. Okay, so all of the lines should be facing you. All of these lines should be facing you when you glue it down. Okay, and you're going to glue it down on the exponential equations toolkit. And then I need for you to write y equals a parentheses b and then x in the exponent. So please pause the video until you do that. Alright, so you should have this foldable glued down. Okay, opening up the foldable, we're going to look underneath the A, and we have talked about that the A in an exponential equation is going to be what? A is going to be the y-intercept. Okay, so we've got a lot to write under the A and the B. A is going to be the y-intercept. Let's talk about a couple different things about the y-intercept. First of all, y-intercept, we always remember in a table or anytime we're talking about y-intercept, x equals 0. Y-intercept is x equals 0. Don't forget about x equals 0 for the y-intercept. Okay, on the graph, you can look at where the graph crosses the y or the up and down axis is going to be the y-intercept. And something that we've talked about a little bit is that for our exponential equations, if there is not an a value written, so if there's no a value written here, then we've talked about what it would be. What could I multiply b to the x by that would not change its value? I could just multiply it by 1. So a lot of these, if no a is written, are going to have a y-intercept of 1. The two reasons are, one, because anything to the 0 power is 1, and the other reason is because multiplying by 1 doesn't change its value. So that's a couple reasons why anything to the 0 power, or that's a couple reasons why a lot of these y-intercepts for our exponential equations are going to be 1. So for y equals a times b to the x, and this is a little different from when we did y equals mx plus b, our y-intercept, when there wasn't a y-intercept written, was 0, but our y-intercept for an exponential function, if there's not one written, is going to be 1. Okay, under the b, we called the b the growth or decay factor. The growth or decay factor, which is what is being multiplied each time in what the y values are multiplying by each time. The growth or decay factor is similar to slope, except slope is what is being added every time, and this is what I'm multiplying by every time. Okay? How do we tell if it's a growth factor or decay factor? If the base is greater than 1, it'll be growth. If the base is less than 1, it will be decay. And we're going to write something else in here, probably Monday, I think, or later on. We're going to write something else down here. Okay, so pause the video if you have not finished writing this down. At the bottom of this toolkit, let's talk about how we could match an exponential equation and a picture of a graph to see which matches with which. Okay, looking at the equation, how can we tell if it's growth or decay? If the base is bigger than 1 or the base is smaller than 1. If it's bigger than 1, it's going to be growth. If it's smaller than 1 and the base is the number below the exponent or the b value, okay, so that's how we tell if it's growth or decay. And then on the graph, based on the shape that it makes, it's going to be growth if it increases from left to right. It's going to be decay if it decreases from left to right. So that's part of the way that you can tell which equation matches with which graph if I give you a matching one. Okay, the other thing that we can look at is the y-intercept. How can we tell where the y-intercept is in our exponential equation? The y-intercept is going to be the a value, the number with no exponent. And if there is no y-intercept, the y-intercept is going to be 1. If there is no y-intercept, the y-intercept is going to be 1. And then you could see what matches. You could look at where the graph crosses the y-axis to be able to tell which is which. Okay, so after you copy this down, I'd like for you to grab the practice that you should have, the exponential functions practice. And what I want you to look at is see if you can match all of these graphs with the equations without a calculator. Okay, so this whole front side of the practice is going to be using this right here to try to match the equations and the graphs on the front, okay, that you should be able to match them by looking at the y-intercept and the growth, if it's growth or decay. Okay, you can pause the video until you have matched all of these on 1 through 16. Okay, next I'd like for you to grab the toolkit that looks like this percents toolkit. Okay, and what we're going to do is we're going to spend a little extra time reviewing percents because in the past I have found that students struggle immensely when we are talking about percents. Okay, so this part you should be good at, talking about going from a decimal to a percent or a percent to a decimal. Okay, if we are taking a decimal to a percent, so for example 0.35, if I want to make it a percent, I just need to move the decimal, and a lot of times students forget which direction. We would move the decimal right twice. Okay, so I'm going to move the decimal to the right twice. 0.35 is the same as 35%. Okay, if there's not a number there, you could put a 0. So this is the same as 40%, 0.4. And if there's no decimal, this decimal would be after this 2. So this would be 200%. Okay, now going backwards to change a percent back to a decimal. Then obviously we move the decimal to the left twice. We move the decimal left twice. Okay, so there is no decimal here right now, so it would be here. I move it to the left twice, and as a decimal, this would be 0.35. 7% as a decimal, I can move it to the left to be 0.07. And 100%, I can move it to the left twice to be 1 or 1.00. Okay, it is very important that you know the difference between when you move it to the left and when you move it to the right. Okay, the problem that I have found is that students get confused, especially when if the number has a if it's like 1.02%, and I want to change that to a decimal. And a lot of times students get confused. Well, do I go to the left or do I go to the right? Okay, I came up with a silly way, a very silly way that you can remember when you move it to the left and when you move it to the right. My silly way to remember is that if I give you a question that has a percent sign in it, if I give you percent in the question, notice these, we added a percent sign, but if I give you a percent in the question, okay, this is a silly way to help you remember that that's when you move it to the left. And the way you can remember that is if you take the percent sign and you picture Beyonce. Why would you want to picture Beyonce? Okay, so that's a little silly way to remember for the Beyonce song. If Beyonce is there, you move the decimal to the left twice. For the questions where Beyonce is not there, you move it to the right twice. All right, now that should be something you already know. Now here's what we're going to do is something a little bit new. Okay, we're going to make a value grow or decay by a percent. And in order to do that, we are going to multiply by something. So for example, if I have a $24 item and I want 7% sales tax, okay, let's figure out what I could multiply 24 by. Okay, now obviously I know a lot of you know that if I multiply this by 0.07, that's going to give me how much the sales tax is, and I would need to go back and add it to the 24. But what I want to do is see if I can multiply 24 by something to get 25.68, to just go ahead and get that number without having to do 2 steps. Okay, so if I want to multiply by something and I want it to get bigger, what do I have to multiply by? If I want something to get bigger, I need to multiply by a number bigger than 1. So here's what we're going to have to do. If you want something to grow by a certain percent, you are going to multiply by 100% plus the percent growth. And then you're going to change that to a decimal. Okay, so let's think about what that would be. If I have the $24 and I said I need to multiply by something, I want to keep 100% of this 24 and I want another 7%. So I would take 100% and I would add 7%, okay, because I'm keeping this 100% keeps this $24, the 7% adds another 7%. So this is 107%, okay. Now you cannot type a percent sign into the calculator. Unfortunately, you cannot type a percent sign into the calculator. So in order to type this into the calculator, we're going to have to take away Beyonce here, the percent sign, and we're going to have to move the decimal to the left twice. So in order for something to get 7% bigger, I can multiply by 1.07. So $25.68. Okay, you need to understand, yes, I know that you could have multiplied by 0.07 and then added that to the original amount. But in order to do what we're going to be doing in the future, you need to understand how to multiply it by just one number. Okay, and remember, in order to get bigger, if we're including 7% sales tax, we've got to multiply by something bigger than 1. If we just multiply by 7%, it's not going to get bigger. Okay, so let's try another one. Your restaurant bill was $16.77. We want an 18% tip. So I've got the $16.77. Okay, to include the 18% tip, when I multiply, I'm going to multiply by 100% plus 18%. Okay, so what would that be? So I'm going to multiply by 118%. Remember, if we multiply by a number bigger than 1, it will get bigger, or bigger than 100% will get bigger. And if we're including the tip, it's going to get bigger. So 118%. So of course I cannot type 118% into the calculator, so I have to get rid of the percent sign, and I can multiply by 1.18. Okay, so 1677 times 1.18 gives me $19.79. So again, if you want something to grow by a percent and you don't want to find the percent and then go back and add it, you're going to multiply by 100% plus the percent that you want it to grow. Okay, let's think about if we want something to decay by a percent. Okay, so let's think about if I have a $24.99 sweater and it's 20% off. Okay, so if I do $24.99 and I want to take 20% off, okay, if I just multiply by 20%, Is this how much I'm going to be paying for the sweater? No, that's how much off it is. So what do you think we're going to have to do? To make it grow, we did 100% plus the percent growth. So to make it decay, see if you can guess what we would have to do. We would have to multiply by 100% subtract whatever the percent decay is. Okay, and then you're going to have to change that to a decimal. Okay, so what could I multiply 24.99? Instead of finding 20% and then going back and subtracting it, I want to multiply by just one number. So I would take 100% subtract 20%. Okay, so that would be 24.99 times 80%. And I can't type 80% in the calculator, so instead what would I type in? I would type 0.8. Okay, and let's think about why that makes sense. 24.99, whoops. 24.99, let's see why it makes sense to multiply by 80%. It makes sense to multiply by 80% because that is the percent of the value that you are paying. Okay, if the sweater is 20% off, then you are paying for 80%. Something you're going to hear me say over and over is that you always multiply by what you are keeping. Okay, here I'm keeping 107% of the value. Here I'm keeping 80% of the value. And think about if it's above 100, it's going to get bigger. If it's below 100, it's going to get smaller. Okay, but you multiply, always multiply by the percent that you are keeping. Okay, the value of a $22,000 car depreciated. Depreciate just means it goes down 10%. So if I have a $22,000 car, I want to take away 10% of the value. So I would have the 100%, but I'm taking away 10% of the value. Okay, so what percent? 22,000, I'm multiplying by 90%. I cannot type 90% into the calculator, so I would type in 0.9. Okay, and I multiply by, I multiply by the percent that I keep. So if the value loses 10%, it makes sense that we're multiplying by 90% because it's keeping 90% of the value. So 19,800. Okay, so multiply by the percent that is being kept. Multiply by the percent that you are keeping. Like in this case, if you're losing 10%, you're keeping 90%. You're going to hear me say over and over, multiply by the percent that you keep, not that you lose. Okay, for people who are visual, I've made this arrow for us to think about this. Okay, it says if you times by, so what we're going to do in the middle of this arrow is we're going to put a 1. I want you to put a 1 in the middle of this arrow. If you multiply by 1, okay, what happens when you multiply something by 1? If I multiply by something by 1, does anything change? Nothing changes. You keep 100% of what you had before, so there is be a 0% change, and the value of something would stay the same. So keep in mind, if you multiply by 1, you're keeping 100%. Then we're going to go on either side of 1. Okay, we know that if we multiply something by a number bigger than 1, what is going to happen? It is going to grow. And if we multiply by something smaller than 1, it is going to decay. I want you to picture this arrow, and I want you to think about how the closer you are to 1, the less it is going to change. Okay, so if I multiply something by 0.999, is it going to change the value that much? No, because it's close to 1. So it'd be a little bit of decay. Okay, if I multiply something by 1.8, that's going to be quite a bit further from 1. So that's going to be quite a bit of growth. Okay, so let's think about like if I were to multiply by let's say 1.123. Okay, so that's about 1.12. If I multiply by 1.123, it's going to get bigger because it's bigger than 1. I'm going to keep 112.3% of the value. How much extra do I have from 100%? I have 12.3% more than I had before. Okay, so multiplying by 1.123 is an extra 12.3% growth. So if you want 12.3% growth, you would multiply by 1.123. Let's talk about something on the lower end. Let's say I multiply something by 0.93. A lot of people will look at this and say that you lost 93%, but no, this is keeping 93%. You always multiply by what you keep. So if you keep 93%, what percent did you lose? You lost 7%. Okay, so picture this arrow. The closer you are to 1 or the closer you are to 100%, the less you are losing. Okay, let's say I multiply something by 0.65. If I multiply by 0.65, that means I am keeping 65%. How far away is 65% from 100%? That is 35% decay. Let's say I wanted something to grow by 35%. If I wanted something to grow by 35%, that means I would need to be keeping 135%, so I would need to multiply by 1.35. Okay, so 0.65 is 35% decay, 1.35 is 35% growth. Okay, what do you think it means if I multiply something by 2? What percent am I keeping? If I multiply by 2, I am keeping 200%. How far away is that from this 100%? If you multiply by 2, you have an extra 100% that you didn't have before. Okay, so always figure out what it is as a decimal. Figure out how far away it is from 100. Okay, what do you think 100% decay would be? That would mean I would have 0% of what I would have before. I would need to multiply by 0. 100% decay means you lose everything and you're multiplying by 0. Okay, so remember, the closer it is to 1, the smaller the amount of growth or decay. The closer it is to 1, the smaller the amount of growth or decay. Okay, please grab that practice again and let's look at the back. It says, what could you multiply something by using just one number to make a value increase or decrease by the following? Okay, so a 15% decrease. What could we multiply by? Would we multiply by a number bigger than 1 or smaller than 1? Since it's a decrease, our answer needs to be smaller than 1. Okay, since it's a decrease, I want to do 100% and I want to subtract this 15%. So if I want to lose 15%, then I need to multiply by 85%. I want to keep 85% of the value. Okay, I can't put 85% in the calculator, so that would be 0.85. So if I want to lose 15%, I can multiply by 0.85, and that would make it get 15% smaller. If I want to increase 30%, I would need to add 100%. I would need to add 100%. and I would need to keep 130% of the value. Okay, so 130% of the value, I can't put the percent in the calculator, so I would multiply by 1.30 or 1.3. Okay, so that's how you're going to do these. You're going to add 100 or subtract 100% and then change it to a decimal. Okay, just either add 100 if it's increase or subtract 100 if it's decrease. We're going to go backwards now. I'm going backwards. So we added or subtracted 100 and then we moved the decimal 2 places to the left. So going backwards, I'm going to start out by moving the decimal 2 places to the right. If I multiply by 0.96, think about, is that close to 1? 0.96 is close to 1, so the value is not going to change all that much, okay? So it's not going to be a ton of growth or decay. So I'm going to change this. If I multiply by 0.96, that means I am keeping 96% of the value, okay? And then I need to figure out how far away that is from 100. Okay, so how far away is this from 100%? 96% is 4% away from 100. Okay, you would get a negative here, but the negative just tells you that it's going to be a 4%. It says, did the value increase or decrease? So we need to say 4% decrease. Okay, it did say to spell out increase or decrease. So we said it wouldn't be a huge deal if I multiply by 0.96. It's not going to change a lot because it's close to 1. Some people might say if I multiply by 0.96, you lose 96%. No, if I multiply by 0.96, okay, let's say you had $80 or something. If I multiply by 0.96, it is going to get smaller because this is smaller than 1, but it's not going to get too much smaller. It's only 4% smaller because this is closer to 1. Okay, I'll do one more with you. If I multiply by 1.432, that means I am keeping 143.2%. Okay, so I need to figure out how much extra I have from 100. To see how far away that is from 100%, that is 43.2%. Do I have more or less than I had before? Since it is bigger than 1, it is going to be an increase. Okay, so that's how you're going to do these. Make sure you're thinking about what you're doing and not just doing the same things over and over, because you are going to see some of these on the quiz that you take. Okay, so you need to make sure you understand when you add 100, when you subtract 100, and when you go backwards, depending on which type of question that I give you.